Welcome to Dark Sky Dive. Today, we enter the secretive world of aerospace manufacturing to explore a philosophy of quiet determination. In the modern space industry, there are two massive names that are always placed side by side in every major conversation. One side represents blistering speed, continuous testing, and the willingness to accept spectacular failures as a necessary part of the process. The other side represents patience, extreme caution, and a strategy of advancing with steady, unshakable steps toward a very distant horizon. If SpaceX represents the spirit of move fast and break things, then Blue Origin represents a philosophy that is completely different. Their motto is Gradatim Ferociter, which translates to step by step, ferociously. It is a mindset of calculated and relentless progress. This unique philosophy is deeply etched into every single square meter of the massive Blue Origin rocket factory we explore today. As we step inside the factory of Blue Origin, the very first thing that surprises most visitors is the absolute silence. There is no constant noise of welding sparks flying. There is no rushed tempo typical of a heavy industrial assembly line. Instead, you are greeted by vast open spaces, brilliant white light, and component clusters arranged with a sense of artistic order. Groups of engineers work at a speed that is strictly controlled. Blue Origin does not race against the public announcement clock. They are racing against a different metric entirely. They race for long-term reliability, ensuring that what they build lasts for decades. Unlike SpaceX, which is famous for flying early prototypes, Blue Origin spends the vast majority of its time on the ground. Every single design is simulated thousands of times. It is tested in the absolute worst-case scenarios before metal is ever cut. They only choose to fly when the engineers are fully convinced that there are no longer any major surprises waiting ahead. This mindset is very close to the traditional standards of NASA, where failure is not seen as data, but as unacceptable. If SpaceX is famous for the Merlin and Raptor engines, Blue Origin is betting its entire future on the BE engine series. In the engine testing zones, we see the BE3 using liquid hydrogen and the powerful BE4 utilizing liquid methane for propulsion. Methane is considered the fuel of the future. But the biggest difference lies not in the specs, but in risk management. Each engine is tested for incredibly long periods. They run continuously for thousands of seconds to prove their endurance and stability. They are only upgraded when the old version achieves high stability. Blue Origin does not optimize to break speed or power records. They optimize so that the engine runs correctly every single time. Reliability is the only metric that truly matters to them. Blue Origin rockets, especially New Shepard and New Glenn, are assembled with a mindset that is very similar to the aviation industry. Every single part has a testing history. There is complete material traceability and a detailed operational file for every screw used. A single bolt that does not meet the standard can cause an entire component cluster to be rejected and removed immediately. This is where SpaceX is often more flexible to gain speed. But Blue Origin refuses to compromise on their rigid standards. For them, it is better to be delayed by a year than to have to fix a mistake while in space. The Blue Origin factory features high-level clean rooms where temperature and humidity are strictly controlled to protect sensitive aerospace electronics. In these zones, people move slowly and with purpose. Every assembly action is recorded, cross-checked, and independently verified by others. This is not because of a lack of trust. It is because they believe that humans are always capable of making errors. The system must detect the error before that error leaves the ground. Prevention is the cornerstone of their manufacturing philosophy. Like SpaceX, Blue Origin also pursues rocket reusability. However, their approach to achieving this goal is fundamentally different in execution. SpaceX lands in limited conditions and accepts risks to learn fast. Blue Origin reuses only after exhaustive ground testing analysis. They only expand operations when every scenario has been analyzed. The New Shepard rocket has flown and landed multiple times successfully. It operates within a very specific mission scope. It is not showy, nor does it try to break altitude records. They focus only on repeatable stability.
This creates a culture of engineering that values checklists far more than sudden inspiration.
If SpaceX is a startup culture, Blue Origin feels like the military or traditional aviation programs where discipline reigns supreme. Here, the process is more important than speed, and silence usually means that everything is going exactly according to the plan. There are no explosive tests to live stream for views, only technical reports and very minor adjustments made behind closed doors. So why is Blue Origin called slow? Because the public only sees launch days, viral videos, and sensational newspaper headlines. They do not see the 10 years of engine development, the millions of simulation hours, and the hard decisions made. With Blue Origin, not launching is also a technical decision. Jeff Bezos does not talk about getting there quickly. He talks about space infrastructure, factories in orbit, and millions of people living and working off the surface of Earth. To achieve that, the infrastructure must be extremely sustainable. That is why Blue Origin chooses the hard, long path. SpaceX and Blue Origin are not rivals in the traditional sense. They are two different ways of solving the same problem. One side is fast, bold, and accepts risk. The other is slow, sure, and reduces risk to the absolute minimum. And the future of humanity in space perhaps needs both of these paths to succeed. Thank you for watching. We have seen the quiet dedication inside the walls of Blue Origin. It is a testament to the power of patience. Every touch, every check, and every test is a promise to the future astronauts who will ride these machines. They are building more than just rockets here. They are building a legacy of safety that will define the next century. From above, the factory looks like a giant clockwork mechanism. Every gear turns at precisely the right moment, never too early. Heavy components float through the air on cranes, moving so smoothly that they appear to be gliding in zero gravity. Precision is the language spoken here. There is no room for approximation when you are dealing with rocket science. Behind every hardware component lies a mountain of mathematics. The theoretical work is just as important as the physical assembly. Knowledge is passed down carefully. This mentorship ensures that the culture of safety is preserved across generations of workers. They look at the microscopic details because they know that tiny flaws can lead to catastrophic failures in the void. Even the air itself is scrubbed clean. This obsession with purity is what separates a factory from a laboratory. Automation handles the heavy lifting, allowing human minds to focus on the complex problem-solving that machines cannot yet do. When the green lights finally turn on, it is not a guess. It is a certainty, backed by endless data. Robotic precision ensures that every weld is identical. Consistency is the key to predicting how the vehicle will behave, but even robots are checked by humans. Ultrasound scanners peer inside the metal to ensure absolute structural integrity remains intact. As the sun sets over Florida, the work inside continues. The pursuit of perfection does not follow a standard schedule. The lights of the factory are a beacon. They signal that the dream of space is being forged, day and night. The New Glenn rocket stands as a symbol of this ambition. It is massive, reusable, and built to carry heavy loads. Its size rivals the legendary Saturn V, but unlike the rockets of the past, this one is designed to return. The separation in space must be flawless. Years of ground testing ensure that this critical moment happens exactly as simulated. Returning to Earth requires mastering aerodynamics at hypersonic speeds. It is a ballet of physics played out at incredible velocity. The recovery ship waits in the ocean. It is a moving target that the rocket must find autonomously from space. Grid fins guide the descent. These systems have been refined over years of suborbital flights with the smaller New Shepard. New Shepard was the classroom. New Glenn is the graduation. The lessons learned are now being applied on a massive scale. Data from the past informs the designs of the future. Nothing is wasted in the philosophy of gradual, ferocious progress. The morale here is built on success, not hype. Every handshake represents a milestone passed and a risk successfully mitigated. They have created an environment that encourages deep thinking. It is a sanctuary for the mind amidst the high-tech hardware. Before the supercomputers take over, it often starts with a simple sketch. The human imagination is the first step. That imagination is then rigorously tested against the laws of physics. Only the strongest ideas survive this digital gauntlet. Advanced manufacturing techniques like 3D printing allow them to create shapes that were previously impossible to build by hand. Technology advances, but the philosophy remains the same. Use the best tools, but never rush the verification of the result. The payload fairings are massive, big enough to hold entire school buses. They protect the precious cargo during the ascent. Carbon fiber composites provide strength without weight. Every gram saved on structure is a gram gained for the payload. They blast the rocket with sound to simulate the roar of launch. It must survive the noise without shaking apart. The violence of launch is replicated on the ground. If it breaks here, it is a lesson. In space, it is a tragedy. Satisfied nods are common here. They are the result of knowing that the math was correct and the build was perfect. Blue Origin is also a key partner for NASA's return to the moon. Their lander technology is built on this trust. The Blue Moon lander is designed to take humans back to the lunar surface. It requires absolute, fail-safe reliability. There is no runway on the moon. There is no second chance. The landing must be perfect on the first try. Sensors map the terrain in real time. These eyes of the machine must see clearly in the harsh lighting of space. The vision extends beyond landing. It includes using resources found in space to protect the environment of our home planet. By moving heavy industry off Earth, we can preserve our planet as a residential and light industrial zone for humanity. But that grand vision starts with the humble work being done right here. It starts with tightening one bolt correctly. Respect for the hardware is taught from day one. You do not rush something that has to carry human lives. Safety is not just a rule book here. It is a culture. It is the air they breathe and the language they speak. As shifts end, the progress is locked in. Another day, another step forward in the long march towards the stars. The stars watch silently. They have waited billions of years. They can wait a little longer for us to arrive safely. The race is not between two companies. It is a race between humanity and the limits of our own technology. Both approaches are pushing the boundaries of what is possible. They are expanding the envelope of human capability in different ways. For the children watching today, it does not matter who gets there first. What matters is that the door is opened. Soon, the new Glen will roar to life. When it does, it will carry the hopes of thousands of patient engineers. The silence of the factory will finally be broken by the thunder of success. That moment will justify every delay. It will rise not because it was rushed, but because it was ready. Gradatim Ferociter will act as the fuel. Looking back at Earth, the factory is just a speck, but that speck is the birthplace of a new era. Breaking through the clouds requires power. Staying in orbit requires precision. Blue Origin is mastering the art of staying there. Zero gravity is the ultimate equalizer. It does not care about your philosophy, only about the physics of your vessel. For the passengers, the ride must be smooth. They trust their lives to the rigorous testing we have just witnessed. Their smiles are the ultimate product of the factory. That joy is manufactured through years of hard, boring, quiet work.
Good to be back, Commander.
The return is gentle. Parachutes deploy, retro rockets fire, and the journey ends with a soft puff of desert dust. The ground crew arrives to welcome them back. The circle is complete, and the data from the flight is saved. And back in Florida, a new sheet of metal is being cut. The cycle continues, building on the success of today. There is always room for improvement. Even perfection can be refined. That is the essence of the engineer's eternal quest. Time passes, but the mission remains constant. The long-term view requires a patience that spans decades, not just fiscal quarters. They treat time as an ally, not an enemy. By taking their time, they ensure that they do not waste it. The children who dreamt of space are now building it. They carry the torch of exploration into the clean rooms. It takes a village to raise a rocket. This team is united by a shared belief in the step-by-step philosophy. Diversity of thought leads to better solutions. They challenge each other to find the safest path through the dangerous unknown. As the giant rockets roll out, they carry the signature of every person who touched them. They are monuments to teamwork. Standing in the mist, the rocket waits. It is a silent giant, ready to scream its purpose to the heavens. Nature has always reached for the sky. Now, we use our minds and our hands to join the birds in flight. The calm before the launch is profound. It is a moment to reflect on the thousands of hours that led here. The countdown is the final checklist. It is the last chance to say stop. If they say go, they mean it. The decision to launch is heavy, but the confidence in the hardware makes that burden lighter for everyone in the room. Orbit is achieved not by luck, but by design. It is the result of Gradatim Ferociter applied to orbital mechanics. Satellites are deployed to connect the world. The rocket has done its job delivering its cargo safely to the destination. The return home is just as important as the departure. It proves that space travel can be sustainable and repeatable. Two philosophies, one goal: fast and slow, wild and disciplined. They are the left and right hands of our future. The universe is vast enough for both. It is vast enough for all of us, if we can build the ships. From out there, our differences vanish. All that remains is the ingenuity of the human spirit reaching for the unknown. Blue Origin reminds us that slow is smooth, and smooth is fast. They are building a road that will last forever. This has been a deep dive into the quiet giant of the space industry. We hope you enjoyed the journey. Please subscribe to Dark Sky Dive for more stories from the frontier of technology. Join our community of explorers today. Thank you for watching. Keep looking up, and we will see you in the next video. Goodbye.